The second submodule in this first module. So the second area in this first submodule is about challenges and barriers, and I will also talk about factors that you usually use when you do automation projects. So this is a traditional way of thinking, or it was in the 1980s and 90s. So usually you look at one product or one cell. Usually you want to have high volume in order to automate. You want to have few variants. You have stiff automation, which means that the robots are not mobile and the pneumatic solutions are not mobile. Automation is adopted for one cell. It's quite low flexibility in terms of routing and path flexibility. And few setups, but the setup times is quite long between the products. And as you see in the picture, usually these factors are taken into consideration. Product volume, as I said, usually you want to have a high product volume if you want to have an automatic assembly or automatic system. If you have many variants, you usually go for manual work or manual assembly. Also, if you have high demand on flexibility and usually low batch sizes due to the setup time. But if you look at the future mindset, this could be new factors that would be taken into consideration. And I will talk about level of interaction and level of interoperability in the market submodule. But for the future mindset, usually you have several products and them together give a high volume. So usually you add products to the cell or to the station in order to get the high volume. You have a more flexible automation. Automation could be adopted for several cells, so you can move maybe the robot or the automation solutions between machines or cells. Focusing on automating tasks instead of entire stations. This, on one hand, as we will see later, could be quite tricky because sometimes maybe it ends up that the operators will do monotonous and quite heavy lifting tasks. So you need to be a little cautious when you automating tasks. Usually, or we see that there is a trend towards increasing flexibility. So you want to have high flexibility and more setups, which means that you need to have shorter setup times between the products. And lately, there is also a trend towards collaborative applications. So then you can actually look at the type of task. If it's a complex or simple task, and simple task could be, for example, pick and place tasks, load, unload, those kind of tasks. Complex task could be if you need to have a certain pressure or something like that. Polishing, for example, is quite hard because then you need a lot of sensors and so on. Level of interaction, I will go through that. As I said, we have 4 different levels of interactions between operators and robot, from coexisting to collaboration. If you have demand on flexibility, if you have low demand on flexibility or high demand on flexibility. If you have low demand on flexibility, you can actually have stiff automation. And I will show you an example of low-cost automation, which is quite stiff because you don't have the demand on flexibility. And then you have something called interoperability, which is the communication between systems, machines, robots, humans. So levels of interoperability. So these are some of the factors that you also need to consider. In 2017 and 2019, until 2019, I ran workshops with a total of 68 Swedish companies, 10 bigger companies and 58 SMEs, where we actually asked them what are the challenges that they see with collaborative robot applications, and what are the most common measures or measurements that they want to improve or have as a factor for changing the tasks. So for the 3 challenges, they said that the safety aspects and lack of good and simple guidelines for design of safety collaborative workspaces. Often you maybe hire a consultant company. You don't trust to build these kind of collaborative work cells by yourself, because it's quite a lot for the risk analysis to consider. The interaction between man and robot, and also production IT, and here is the level of interoperability. And the product, it's usually not designed for automation, but for manual work. So the lack of fixtures, positioning, and so on, which is needed if you want to have a robot application. And the 3 key factors that has been identified. So usually companies want to improve ergonomics by automating monotonous and non-ergonomic tasks, increased quality or more even quality in the task, and also resource flexibility, so that operators can do other things, maybe quality assurance and so on, or small sub-assembly, and then the robot can do other things. So these are the 3 main challenges that we have seen, and also the main key factors. As I said before, there is an optimum between human and technology, and this is a paper that was written 4 years ago, but it's quite interesting also for the discussion. So you have they have listed some dilemmas, you can say, or contradictions. So automation requires no advanced competences. Automation leads to specialized competences. Proactivity and revolve is assumed to rely on holistic understanding. Technology and product development pushes early variants in the process. A broad engagement early in the automation process secure good solutions, and individual engagement and responsibility drives development. So these are some of the factors that they have seen when they have interviewed, or when they interviewed companies. We see that there are some robots that requires quite a lot and advanced competences, but there is also robots that are quite easy to program, as I will show you later. So you don't need the advanced competence. You need to have the competence in the holistic view and holistic understanding. It's most important when it comes to the safety issue and the risk analysis, I would say. And this I discussed earlier. Automation leave boring jobs, hanging, feeding, piling. So this you need to also consider. So this was what I talked about earlier. Automation leave boring jobs, hanging, feeding, piling, etc. So this you need to consider in the task allocation that we will talk about later. Flexible and multi-skilled workers are appreciated. I think they will still be appreciated even though you have a high level of automation. You need to have the flexibility, and you need to have workers and operators that could solve problems and that could be flexible. Automation and specialization leads to expert roles and procurement or functions. Could be. I will talk a little bit about automation specialization also. Strive for standardized process and few variants in manufacturing. As I said, if you want to have high automation, you want to have fewer variants, and that's also why we saw in the Volvo movie that the level of physical automation is higher when it's less variants. So that's why it's more and more manual the closer you get to the final or finished product. This you also need to look at the roles. We'll talk about that more when we talk about strategies. Also group rules within functions. We will talk about that also when we talk about strategies. So these are some of the challenges and also some of the barriers. We can see barriers in both the organization, in the technology, in the process, and maybe also in the economy, how you count the payoff and the budget for an automation project. So this is it.